All right, so we left off right here, and let me reiterate what I was saying before, which is that if it's an increasing line, now remember we always read graphs from left to right. So you start at the low end and increase as you go from left down here to right up here. That's an increasing line. So this is a positive slope, right? And now a negative slope is a decreasing line, because if you start on the left, you're high, and then if you move to the right, you get lower. That's decreasing. So that's a negative slope. Okay? All right, now what about horizontal and vertical lines? Hold on one second. Let me go get the picture for that. Poof, there we go. All right, so, and I've even labeled the figures. Well, actually, the book didn't. I'm just sticking with it. Okay, so if it's a horizontal line, that's the one on the left, right? So you can imagine if it's horizontal, that's flat, right? Like when you have your table at home, it's got zero slope. If you put a pen on it, it won't roll away. That's zero slope. Insert a, let me underline this just a little bit. Zero slope, right? Okay. Now what if it has a vertical line? Well, vertical line is what I was getting at up above. It's an undefined slope. So let's make a note to ourselves right here. This guy right here, over -4 up 3 over 2 up 3. It's a horizontal line. So it has zero slope. So we can make a note of that. Note, horizontal line. Oops. There we go. And this one with an undefined slope, if I had it, would have been a vertical line. All right? So horizontal line, zero slope. Vertical line's undefined slope. I don't ever use the no slope. Everything's got a slope. It just might be super, super steep. So usually no slope gets attached to the undefined slope. So just call it undefined. All right, next I've got some graphs here all on a page, and I'm going to have to zoom out a little bit, but look at it on your paper. And the idea is you want to put these graphs in order from shallowest to steepest. And we're not going to care about whether they're increasing or decreasing. We just want to care about their steepness. So, and we can even measure their steepness, to be honest. Let's do a little bit of legwork here. This one's increasing. Hopefully you guys all see that going up. This one's decreasing. So it's going to have a negative slope when we find it. This one's increasing. I know it didn't ask us to do this, but it pays to do all this legwork and kind of figure some stuff out. This one's decreasing. This one has zero slope. This is a horizontal line. So I can tell you right now, M is 0 on this one, right? And this one is a vertical line, so I can tell you right now that M is undefined, right? Undefined, really big. All right, so we've got some M's already going here. Now, it didn't ask us to find these other M's, but why don't we find them anyway? Just because that's a good skill to have. So what you can do is you don't need points. You don't need the formula. You kind of look at the graph. So you can see here I'm circling with my cursor a little bit. There's a point right here that's on the grid. You see it? And then there's another one. Let's see. Next one's right there on the grid. So if you want to start at the low point and work your way, you got to go rise over run. So you go up 2, right 1. So your slope is rise 2, run 1. So your slope is 2 over 1, which is 2 for that one. I know it didn't ask us, but let's do it anyway. Let's get this done. Okay, so now what about this one? Okay, slope is, let's get some points first. So you got to look on the graph to find some grid points. And honestly, this one, you can get 6 right there. See that? And then there's another one at there. And then there's another one right here. And you're learning something very valuable. Do you see how this line is coming across the diagonals? Do you see that? that means something very special about the line. Namely, it has a kind of special slope. So your rise is you drop -1, right? Because you go down 1, then you go right 1, which means your slope is -1. And it's a thing to note to yourself, right? If it goes across the diagonals of the squares like that on the grid, then it's a slope of either 1 if it's positive or -1 if it's negative, like this one. All right, now what about these? Let's see here. I got to find some points on the grid. So looks like we go through 0, 1, and then I got to keep searching for another point. And looks like 5, 2. Okay, so my rise is 1, so I lift 1, run 5. So my slope is rise of 1, positive 1, run of positive 5. There's my slope, 1/5. Okay. All right, now what about the last one? Let's get some points. So it looks like it goes right through 0, 4, so I'm going to put that one in there. And then doesn't go through the grid, not on the grid, not on the grid. There's the next one that's on that. So you're looking for ones that hit kind of the corners of those grid marks. All right, so what's that slope? It's going to be negative because we're dropping, right? You're going down 1, so it's -1. And then we go 1, 2, 3, 4 over to the right. So -1/4. Cool. We've just found a whole bunch of slopes. That's a good thing. Now, they also want us to know how to do this, put these in order from shallowest to steepest. So that's a little bit of a tricky proposition, because what they're implying there is don't pay any attention to the positive negative thing. Just pay attention to whether it's shallow or steep. All right, poof, like that. I'm going to put it down at the bottom here. I think that'll help. Okay, so we need to figure out what our shallowest graph was. All right, now if we're not going to care about positive or negative, right, let's think about this. Shallowest would mean if you're on a pair of skis, right, you're not going to go very fast down this hill, right? As a matter of fact, the shallowest graph is one you wouldn't go down at all. It's this one over here, right? It's the 0. The 0 is the shallowest graph you have, because if you're on skis, you're not going to roll. You're not going to fall down. Or skates. Imagine yourself on rollerblades. I don't care. A skateboard. Put yourself on a skateboard. If you have a hill that looks like this, that's not a hill. That's a flat piece of road, and you're not going anywhere unless you push yourself. Okay? All right. Now, by that same token, the steepest graph is the one that you would fall to your death on. That would be letter F, which is actually the vertical line. So that would be undefined. That's going to be the steepest. Now the question is, how do we fill in all the spots in between? Okay, so this you'd fall to your death. This you would fall nowhere. Let's find all the spots in between, shall we? Okay, so when you're looking at these, which one's the one besides the flat one is the one that you would go the slowest on? Like if you were on skis or skates, which hill would you be rolling down the slowest? Well, that's this one right here, right? 1/5, because it's the smallest, right, number out there besides the 0. Again, the whole positive negative thing is irrelevant. Positive just means one way you're climbing and one way you're falling, but either way, right, it's shallow, right? It's the easiest slope to climb. It's the easiest slope to fall down. That's kind of a depressing thought. I want to imagine myself falling down things. Okay, then what about the next one? What's the next easiest slope to climb? If you're a lame climber like me, that would be this one right here, the -1/4, right? Because -1/4, even though it's negative, that just means, you know, hey, I'm falling down this one instead of climbing up it. But it's still quite shallow. Easy climbing. Okay? All right, now what about the remaining two? This one's a -1, this one's a 2. Of those, this -1 one is next in line because, yeah, it's really steep, but you know, if this was a staircase, if this would be quite steep, but you wouldn't drain yourself nearly as fast as you would on this one. Look at that staircase. I mean, this would be dangerous. If you were falling down this staircase, you'd be falling to your demise, right? So you break your neck on that other one. You good? So the bigger the number is in magnitude, magnitude means you pay no attention to its sign, just look at it. If you look at that number, the bigger the number is, the steeper it is. The positive negative thing just means I'm climbing or falling. That's it. right? So you kind of ignore that. But the steepest is the undefined one. That's the kind of thing Tom Cruise does, hanging outside a window in some movie, right? And then 0 is the kind of slope I like, easy peasy. All right, last but not least, what about parallel lines and perpendicular lines? Let me go get the answers and I'll be right back. Okay, poof, like magic, there they are. They changed color, but those are the right answers, I swear. Okay, so if the lines are parallel, what does that mean? Okay, now I drew a picture down below. Actually, I copied a picture. All right, so here it is, right here, two parallel lines. Right? Now notice their slopes. Right? Slope is a measure of their steepness. Compare the steepness of the blue line and the red line. They're the same, right? So two distinct lines have equal slope, then those lines are parallel. Right? They have the same slope, they're parallel. Distinct just means they can't be the same line, like one on top of the other. All right, now what about perpendicular? Perpendicular means they meet at a right angle. Do you remember right angles? They're kind of important. Look in the room around you, wherever you're reviewing this. There's probably some right angles, right? Like in the ceiling tiles and the floor tiles, or where the wall meets the ceiling, and I don't know, the corners on your doors and stuff. That's all right angles. Okay? So when two lines meet at a right angle, then their slopes are opposite reciprocals, because one's got to be positive, one's got to be negative, right? So if the red one's positive, the blue one's negative. See that? That's always going to happen with perpendicular lines. And then if this one, let's say, let me make an example up for you. Hold on. Oops, there we go. Okay, so if I look at line 1, I can see that's a decreasing slope. So let me just make something up. What if it was like negative, oopsie, negative 4/7. I hope that's not an example I give. Nope, it's not an example I do yet later. Good. Okay, so if I say that slope is negative 4/7 for the blue line, then what's the slope for the right or the red line? Well, it's got to be positive. So the slope for the second one would be positive. So since this one was negative, the other one's positive. And then you flip it, 7/4. They're opposite reciprocals. Sometimes it's called negative reciprocals of each other. By the same token, what if this one, just for the fun of it, what if the slope on this one was 12/13? If the blue line has a slope of 12/13, then guess what? The red line does too, because they're parallel. Good. That give you some examples. All right, now given that is the case, then let's look at this problem right down here. So we're supposed to look at these and determine whether they were parallel, perpendicular, or neither. Well, hopefully everybody can spot the middle one. That's parallel, right? They are the same number. Both of them are 7, right? Okay, so then what about this one over here? 2/5 and -5/2. Well, they're reciprocals. One's 2/5, one's 5/2, and they're opposites. So this is perpendicular. And then this one over here is neither. It's close to being perpendicular because one's 3/8 and one's 8/3, but the problem is that you need one to be positive and one to be negative for that to work, and you didn't have that in this case. I just want to make one other quick note. There's a special case of perpendicular. Ooh, perpendicular. There we go. So it's the horizontal and vertical lines are perpendicular, right? So I better put that in there. All right, so the horizontal and vertical lines are perpendicular to each other, but their slopes don't do this opposite reciprocal thing. That's why they say, see that? Non-vertical perpendicular lines. See that line right there? They're not saying that for nothing. They're saying non-vertical because this whole negative flip-flop thing only works for diagonal lines, right? So if you have horizontal and vertical lines, then what's going to happen is that they're perpendicular. The one slope is 0, the other slope is undefined. That's how we're going to do it. Okay. All right, we're done with that section. I'll meet you back here for 1.4. See you then.